C is a very interesting language, and in this video we would look at different aspects of C with a lot of aptitude questions. We will look at a lot of puzzles and we'll try to understand C more. You would look at a lot of puzzles first and then we would discuss the answers for them. Be patient for the first few minutes and then you should really enjoy this video.
I have a long L which is assigned to 1. So a value 1 is assigned to this, and I have a float j to which a value 10.0 is assigned. And I'm doing a printf. So what I'm doing is printing %d, the size of L, and size of 1, size of j, and size of 10.0. So basically I'm printing the size of each one of these things which is present in here. So L 1.1, J 10.0, and I also prefixed it with the respective things so that we are sure of what it is in the output. So it's time to pause the video and think what the output is before we discuss further. So you can pause the video now. Welcome back. Hope you thought about it and you understand or you know something about what the answer is. Let's run this program and see what the output is. Okay, this is the output. What I would do is I would just take it and put it in here so that it's very clear to us where different things are coming from. So L is 8, 1 is printing 4, J is printing comma here. So this is the output, and now let's discuss why this is the output of this particular program. First thing is, in my compiler, if you look at it, long has a size of 8 bytes and 1 has a size of 4 bytes. J is a float. Float has a size of 4 bytes. So in the implementation where I'm running this C program in, the size of the long is 8 bytes. The first thing to remember is the size of any data type in C language is implementation dependent. There are certain constraints which are imposed by the C language, but the actual size itself is implementation dependent. So if you run this program probably in a different computer, probably you would get the size of a long variable might be 4 bytes, might be more. But there are certain constraints which are posed by the C language definition. C language specification. Thing is, the shorts and the integers should at least be 16 bits, that's 2 bytes. And the longs should at least be 4 bytes. So a long should at least be 4 bytes and long should be greater than the size of an integer. Let's move on to this discussion about this particular program. So you see that 1 is printing the size as 4 bytes. Why is it so? Because when I say size of 1, any integer constant by default is of type integer. And when I said size of 1, it's printing the size of integer. So in my particular compiler, the size of integer is 4 bytes. And the default constant type for a floating point is a double. So when I say any floating point constant, 10.0, 20.0, the default type is double, and the size of double in my implementation is 8, and that's why 10.0 has a size 8. However, when I'm storing 1, which is an integer, into a long variable, it is stored in, it is upcasted and it is stored as a long into a long variable, and that's why when I print the size of L, it prints 8 as a long variable. And here, when I store a double constant into a float, something called downcasting happens. So a double is converted into a float and the value is stored into J. So the value 10.0 is stored into J, and the value when I print right now, when I run the program right now, is as we saw earlier. So things which we learned in this particular puzzle is, one, the size of different types is implementation dependent. 2, the default types for an integer constant is int, and the default type for a floating point constant is double. And when you store one variable type into another, upcasting or downcasting would happen. I can make these variables, I can change the type of these constants by putting 1L, that's 1 long, and I can say 10.0f to make it a floating point constant. So if I do something of this kind, you'd see if I do size of 1L and 10.0f, you'd see that both these are the same and both these are the same, because what we are printing here is not the size of 1, but we are printing the size of 1L and 10.0f. And you'd see that the size of 1L is 8 and 10.0f is 6. Because now when I do 10.0f, the constant becomes a floating point constant and it prints the size of a float. So there you go. I hope that was an interesting puzzle to start off with, get an understanding of the size of different variable types and constants in C language. Let's now look at the next puzzle. Float percent is equal to 0.0f, and what I'm doing here is I'm looping over it 10 times and adding 0.1f 10 times the percent, and I'm checking if percent is equal to 1.0f and printing equal if it is and not equal if it's not. You can pause the video now and you can think what the output would be. Think about it and come back. Welcome back. Hope you thought about the answer, and let's see what the answer of this particular program is. It's not equal. Why is it not equal? It's not equal because floating point calculations in C are not absolute calculations. Floating points, when I say 0.1, inside it is stored at something like 0.0999999991, something of this kind. I'm not just saying this is the absolute value which is used to store 0.1, but it could be something of this kind or it could be something of this kind as well. When a C language stores floating point, it doesn't store the exact representation of the floating point. There is a minor variation in what it stores, and when you use it for calculations, it makes a huge difference. Especially for financial calculations, avoid using floating point calculations. So do not use float to represent anything which you use in a particular calculation. So if you wanted to see what exactly was used to store this, I would actually now print percent and let's not equal and percent f. I would print it to the accuracy of, let's say, 20 decimal points. Let's see what the value is. So as you can see, the value which was stored into percent is not 1.0 but 1.000. These first 6 decimals match, but if you look at the rest of the decimals, they are way off. So this is the reason why you should not use floats for doing any calculations. Hope this is an interesting puzzle. In this puzzle, let's look at the concept of expressions. I have 4 different variables, 4 different types, and I'm assigning integer is equal to long, is equal to float, is equal to double, is equal to 3 by 2. And I'm printing the values of them to the console. So what would be the output of this program be? You can pause the video now, think about it, and come back. Welcome back. Let's run this program and see what the output is. Okay, this is the output. Let's copy it. So the integer value. So if you see, everything is a value 1. What is the reason? First thing is, what happens with an expression of this kind? 3 by 2. What would be the result of this particular thing? 3 is an integer and 2 is an integer. The result of such an expression would also be an integer. So that's the first rule to remember. In any operation involving 2 operands of the same type, the result would be of that type itself. So 3 is an integer, 2 is an integer, the result would be an integer. 3 by 2, the result would be 1, and it will not be 1.5. So it is similar to saying is equal to 1. As we discussed in the previous puzzle, what would happen is 1 gets upgraded or upcasted and stored into double variable as 1.0, and then downgraded to store in float, and then downgraded to store or truncated to get stored as a long, and truncated to get stored as an integer. So that's the reason why you see this output. Integer is 1, long is 1, float is 1.0000, and double is 1.0 as well. So that's how it would get evaluated. Let's say I changed this to do something of this kind. So now I'm storing 3.0. So I'm saying 3.0 by 2. What would be the result of this? So the result is something of this kind. If you'd see, the change is that instead of 1.0, the float and doubles are 1.5. That is because of the change we have done. So when 3.0 is made, 3 is changed into 3.0, what happens is that now this expression or this operation 3.0 by 2, one of the operands is a double. 3.0 is a constant floating point. A constant floating point is always by default a double. So 3.0 is a double, and a double is being divided by an integer. So a double divided by an integer, the result is always the larger one. So double is the larger one, or double is the higher type. Floating point numbers, floating point is the higher type. So double is a floating point, so it's a higher type. 3.0 by 2, so that's 1.5. So 1.5 is the result of this. So 1.5 gets stored into double, same thing into float, and or 1.5 truncated and stored into, or 1.5 is converted or downcasted and stored into float. And when it's stored into long, it's truncated. 1.5 becomes 1, and yeah, same when it's stored into integer. So that's the reason why you see this particular output. Let's say instead of 3.0 by 2, I change it to 3 by 2.0. Do you think there would be a change in the output? There will not be, because 3 by 2.0 is also the same. I mean, 3 is an integer, 2.0 is a floating point, that's a double. So operation involving floating point and integer would result in a floating point value. So floating point and number operation, it would always result in a floating point value, which would be 1.5. So let's run this. Let's make sure. Please do save. Yeah, you'd see that it's 1.5. So you can see that everything, the output remains the same as what it was earlier. So that's about 2 different things. One is result of an operation involving different types would be always of a higher type. And the second thing is, whenever you store any value into a variable of a higher storage or a lesser storage, the respective truncation or respective upcasting would happen. In C, it's not a compilation error to store a different value of different type into a number. For example, do you think this would result in a compilation error? In C, it won't. It would compile, give some output with some default values for all this stuff. But in C, this will not be a problem at all. What would happen is 3.0 gets truncated and stored as 3 into the integer variable.
Welcome to section 4, expressions. Expressions are kind of the fundamental to programming. So it's very useful or very good to have an in-depth understanding of them. In this section, we would look at varied kind of puzzles related to expressions, precedence, and associativity. In this particular video, let's start with expressions. Welcome to the next set of puzzles. In this set of puzzles, we'll look at mostly expressions, but maybe a little bit of others as well. Let's get started. Whatever you see on the screen is the next puzzle that we want to answer. What would be the output of this particular thing? So I have an integer variable and I'm assigning 10 into 4.5. So whether the output is 10 into 4, 40 because it's an integer, or whether it's 45 because 10 into 4.5 is 45. So how does it get evaluated? Think about it and come back. Okay, hope you got the right answer. Let's run it. What's the answer? I had printf instead of printf, and that was resulting in compilation error. That was not really the intention behind this puzzle. It was something else. So please ignore the fact that there was a printf and not printf. Now I put printf in. If you thought that was the answer, you can go and rethink the answer for this puzzle and come back. Let's run this program. The answer is 45. The reason is, as we have discussed in one of the previous videos, any operation, the result of it would be the higher of the operands. So here there are numbers as well as floating points. Floating points is considered to be higher than integer. So the result of this would be a floating point operation. So the result of this would be 45.0. And the 45.0, when it's stored into a smaller variable I, it's truncated. So float, when stored into an int, gets truncated, and 45.0 becomes 45, and that's the value which is printed. Quite simple, isn't it? Let's now go to the next one. So I'm doing something of this kind, 5.0 mod 3. What would be the output of this particular thing? Think about it. Is to save, and it's a compilation error because you can use a mod only on integer kind of values, not on floating point values. Next puzzle, I'm using a mod on characters. Do you really believe it? On characters. What would be the result? The first question is this a compilation error? The second question is, what would be the result? 2 points if you get the right answer. Okay, let's run this. The answer is 2. It compiles, first thing, because you can use characters wherever you can use numbers. So you can even do things like C star A, and as you would guess, it would print a number 9603. So wherever you use a number, you can use characters, because internally characters are represented as numbers in C programming language. So you can use characters wherever you would want to use a number. That aside, when we did this, I got an output as 2. How was it? That's quite a simple thing. Let's just assume A has a ASCII value of 50. I'm just assuming it has probably a ASCII value of
92 or something, whatever it is, it doesn't really matter. So A has an ASCII value of 90, let's say. Then C would have an ASCII value of A, B, C. So 90, 91, 92. So it has 92. So 92 mod 90. Even if it was 82 mod 80, 72 mod 70, it doesn't really matter. The answer would have been 2 because C is 2 characters after A. So that's the answer to the puzzle. Now we move into the familiar territory of I, J, K and printing the values of I, J, K. I guess this is how most of the puzzles are usually, and now we get into that territory. So this puzzle, I has a value of 5, J has a value of 6, and K is equal to I++ or J++. I could have made it much more trickier by doing something of this kind. Yeah, but it's the same as what it was earlier. So what would be the result of this particular thing? So I would want what is the value of I after this, what is the value of J after this, and what is the value of K after this. Think about it, take a break, come back. The output is 6, 6, and 1. So it's printing, the output which is printed is I is 6, J is 6, and K is 1. How is it so? The first thing is the value of any logical operator, an OR, an AND, all those kind of operators will result in a value 0 or 1. That's first. 1 represents true and 0 represents false. So the result of this entire operation would be a 0 or a 1. K gets a value 1 because, as we know, the result of this operation is true. Why is it true? In C, any non-zero number is considered to be true. Here, I++, the result would be 5. It's a non-zero number, so this is true. And J++, this is also a non-zero number, so the result should be, at least if one of them is true, then K should be true. So K is assigned a value of 1. So that's out of the question. So this we know why. So we know why K gets a value 1. So that's done. Now, I is 5. It becomes 6. That's good because I did a I++ here. J is 6, but it remains 6. Why is it so? That's because, let's say I did this I++ single or J++. What would be the output? As you can see, I remains 6, but J becomes 7. Whereas if I used this, I was 6 and J is 6. The difference is that a double OR is called a short circuit operator. When it knows that the value of the expression is true, it will not execute the right side of the expression. So if it knows that the value of this particular expression is true, it will not even worry about executing anything after that. So in here, I++ is true. So once it's true, the result of the OR operation is always true. So it goes and returns back the result of that operation and returns a value true back. So that's the difference between a short circuit and a non-short circuit operator. Double OR, this is a short circuit operator, whereas this is not a short circuit operator. Let's now think what would be the result if it's AND. So instead of OR, I'm using AND. I++ and J++. What would be the output? You see that the increment of J is also happening. That is because I++ is not a conclusive evidence. So this is true. But just with this, the result of operation is not determined, because for a result of an AND operator to be true, it needs to execute both sides of the thing. So it executes J++ and then it's able to say that the value is true. So it returns back a value true, but both values are incremented. What would have happened if the value is 0? Think about it. So it's I++, the value of I is 0, and I'm executing an AND operator on K. Let's even make J as 0. It makes it easy for us to understand. So what would be the output? That the result of the operation what would be the output? So let's also print k if we want to be really sure. So think about it and come back. The output is I1 J0 K0. Why is it so? Why is I1 J0 K0? Because I++ happens, but I++ returns a 0. I++ returns a 0, and if this value is 0, then it means it false. Non-zero value is true, 0 value is false. So even though I++ happens, I++ is post increment, so it returns a value 0 back. So I++ is 0, and with this itself, if this is false, the result of this AND operation is false. So it doesn't need to execute J++. So J++ doesn't get executed, so J remains at 0, and the value false is returned. The value false is represented by 0, so that's what is returned back. So same thing, let's say we did this ++i and ++j. Think about what would be the output. I'll run the program right now. The output is I1 J1 K1. The difference in the output is because instead of doing post increment, we are doing a pre-increment. The pre-increment returns the result after the operation. So ++i, I0 ++i returns 1. So I becomes 1, the operation returns 1. So ++i is 1. That's true. If this is true, then the operation value cannot be determined by the AND operator. So it executes the right hand side as well. ++j, j is 0, 0 becomes 1. The value 1 is returned, j becomes 1, and 1 and 1, true and true, is true again. So k becomes also true. That's 1. So 0 or any of these things, actually k can be 1 or any non-zero value. In this particular situation, k is assigned a value 1, and I1 J1 K1, and that's what is printed to the output. So I hope this was clear about short circuit operators and non-short circuit operators. One other thing is the result of this operation, I++ and J++, that's the value which is stored in k, can be a little different sometimes. I mean, as long as the k represents true or false, that's what C tells you. So k, any non-zero value represents a value true. So the result of this operation can be any non-zero value. So if I have a value of 5 and this has a value of 7, k can get any value. It doesn't have to be a 0 or 1. K might have some other value as well. So if I do OR, I'm trying to see if k gets a different value at any point in time. Yeah, here it's getting 1. What would happen if it's this? Oops, again 1. I'm trying to simulate a situation where k gets some other value. Over here, you can see that k gets a value 6. The thing is, it can happen that k gets a value which is anything other than 1 as well. But the most important thing C compiler would guarantee is that this would get a non-zero value representing true. So if the result of operation is true, then the value of k can be any non-zero value. So anything that represents true might be stored in k. So you can't be sure that it's always 1. The next one we would be looking at is what would be the output of this. So I plus j plus plus. What would be the result of this operation? It's a compilation error, because you cannot increment a value which is not in a variable. So you can only increment a value and not a variable. So I can do plus plus I, but I cannot do plus plus I plus j. But what happens if I do this? Will this compile? You would see that it compiles, because the way it executes is it does plus plus I and does plus j, and it would be storing the value into k, and plus plus I becomes 6, 6 plus j is 5, 6 plus 5 is 11, 11 is stored into k. So that's how this particular thing would be resolved. So there you go. That's the first set of things on expressions. Until the next set of puzzles. In this particular video, let's look at the different puzzles related to precedence and associative. Let's look at the thing which is on your screen right now. I have variables I, j, k, I star is equal to j is equal to k is equal to 4. What would be the result of this particular program? Think about it and come back. Welcome back. Now, what would be the result of this particular expression? So, I star is equal to j is equal to k is equal to 4. Funny, isn't it? Okay. First thing is, you would never face this kind of programs in real life. I mean, I would really see if somebody writes this kind of a program in a project, then I'm sure he would not be there for long unless he's playing around. Yeah. Now coming to the answer to this particular puzzle, the way expressions are executed is decided by something called associativity. In and precedence. Precedence decides which operator has precedence. So if you have two operators, which one gets executed first? That's decided by precedence. So precedence decides who has priority, whether I have priority or you have priority. Among the operators, which operator has priority? That's basically precedence. If you look at the precedence table, then basically if you can summarize it, it would be something like brackets have the highest precedence. Next goes the unary operator. So if I can summarize the precedence, it would be simple. First is brackets. Brackets have the highest priority. Next goes all the unary operators. The unary operators are, if I want to say +1, that's plus is a unary operator. If I want to call it -1 is a unary operator. Plus is a unary operator. Minus is a unary operator because they operate on single operands. The other unary operators are address of and value at. This is not multiplication. This is value at a particular pointer. This is address of a particular variable. So those are all unary operators. The next comes your multiplication and division. So multiplication, division. So it's not. So the precedence of star depends on the context as well. So if it's used in the context of a unary operator to find a value at, it has higher priority than when it is used as part of a expression to find out multiplication. So star and division. So and the next thing which would be executed would be plus and minus. Again, plus and minus, unary plus is different from operation plus. So next is plus and minus, and the next precedence goes to comparison operators, not equal to actually, and the next precedence goes to all the logical operators, and or, and has higher priority than or, and then comes conditional, becomes too complex. So and at the end are the assignment operators. So assignment operators fall almost to the end of it. So I mean, I would kind of summarize it this way. I mean, this is the precedence. So you start with brackets, unary operators, then multiplication, division, then addition, subtraction, followed by your comparison operators, logical operators, and at the end is assignment. So that's kind of the precedence order which is used. Other than precedence, there is something called associativity. Each of these sets have associativity. The important associativities which you would need to remember would be the ones for assignment. The ones for assignment have a precedence from, have a associativity from right to left. We'll understand what it really means a little later. Right to left. And also the unary operators have the associativity from right to left as well. And most of the other ones, except for the question, this operator question mark colon, this operator also has a right to left right to left associativity. So other than this, all the others have a left to right associativity. Okay, I hope I was not boring you with all this stuff until now. If I have to summarize, then do find an easy way to remember the precedence, because precedence is really important. The way I remember it is brackets, priority highest, unary priority next, then comes the multiplication and division, and then comes addition and subtraction, and after that comes the comparison, logical, and assignment operators. In terms of associativity, the only thing which is important to remember, I think, is for unary operators and for the assignment operators, it's right to left, and for all the other operators except for the question mark question mark colon, which is the conditional operator, except for that, all the other ones have left to right associativity. Now, the associativity here for is equal to, if we look at it, is assignment is right to left. So the way it gets executed is right to left. So first this gets executed, then the result of that is assigned to this, and then the result is used to execute this. So the first thing which gets executed is k is equal to 4. So k becomes 4. The result of that expression is 4. So j becomes 4. So I star is equal to 4. So whatever value is in I would be multiplied by 4. The value in I at that point would be garbage. So you can't predict that. So that whatever value in I was at that particular point in time, it would be multiplied by 4. If you really want to predict it, then probably I have to assign a value to I. Then it becomes 4. So you'd see I4, J4, K4. That's about this particular expression. The most important things to remember would be associativity and precedence, I guess. So let's consider another example. So what would be the result of this operation? 5 by 20 into 4. If you look at the table, star and multiplication and division have equal precedence. So they have equal precedence. So what comes into picture, and what's the precedence? What's the associativity here? Think about it and come back. So do you have an answer? Let's execute it. The answer is I. What we were really interested is in the value of I. It has a value of 0. Why does it have a value of 0? It's because 5 by 20 is first thing is, all these are integers. So whether this was executed first or this was executed first, the result would be 0, because 20 into 4 is 80, 5 by 80 is 0, and 5 by 20 is 0, and 0 into 4 would have been 0. So it's anyway 0, because this is integer operations and not floating point operations. Let's make it more interesting. So what would be the result now? Let's run this. The result is 1 and not a 0. The reason is because star and division have equal precedence. So what decides the order of execution is associativity. And the associativity, as we discussed, for a slash and a star is from left to right. So the way it's executed is, first this is executed 5 by 0 by 20.0. So 5.0 by 20.0, that's 0.25. So 1 by 4, 0.25. And then that is multiplied by 4.0. So 0.25 into 4.0 is 1, and that's the result of this particular operation. If I wanted a different result, I should have used something of that kind. If I wanted to have a multiplication done first, then I would do something of this kind, where now I become 0. The reason becomes 0 because 20 into 4 is 80.0. 5.0 divided by 80.0 is some fraction 0.125, and 0.125 is stored into an integer variable, so it becomes 0. The decimals are truncated, it becomes 0, and so the output for this particular program is 0. Hope that helps you in understanding the importance of associativity and precedence. Let's look at another example. So, how is this evaluated? I plus 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 j? Is it evaluated as I plus 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 j, or is it evaluated as I plus 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 j? Which way is it evaluated? The answer to this also lies in precedence and associative. As we know, Unary has precedence over a plus. So Unary plus plus has precedence over single plus plus. So the first thing which happens is a split. So it would be this or a this, either of them, and then associativity comes into picture, which is left to right for a unary operator. In this video, we will look at in depth about the different puzzles related to expressions. This is expressions part 2. Welcome. Let's continue our discussion with expressions. On the screen right now is a small program that you are looking at. I have a variable I and I have two variables j and k initialized with 15 and 17 respectively, and I'm doing I is equal to j double is equal to k, and I'm printing the values of I, j, k. So quite a simple program. You can try and guess what the output of this program is. Welcome back. I hope you tried guessing or tried to calculate the answer for this program. If you already know the comparison operator, probably the rest of the discussion might be little too simple for you, so you can skip forward. If you don't know the comparison operator, then here's the sum. So the is equal to here is called a comparison operator. We know that is equal to is an assignment operator. What does is equal to do? If consider this part, I is equal to j. If this was the only statement which was present, let's say I is equal to j, it was something of this kind, and what happens in the assignment operator, as we already know, is the value of j is copied into I. The value of j is 15 here, so it gets copied into I, and the value of I also becomes 15. So whatever is the value on the right hand side would be copied into the variable on the left hand side. That's the assignment operator, and we have used the assignment operator a number of times. We are using assignment operator even here as well. So we are copying 15 into j. We are copying 17 into k. So that's quite a common thing that we do. Now, the double is equal to is a comparison operator. Typically, the comparison operators return a value of 0 when the result is false. So a comparison is actually checking something, checking a condition, and when the condition is false, the comparison operators return 0, and when the value is true, when the result of the operation is true, then they return 1 or any non-zero value. I mean, you cannot be sure that the value which would be returned would be 1. It can be a non-zero value as well. So the thing which you can be sure of it will not be 0. So when it's true, it will return something which is non-zero. So it would be some non-zero value which would be returned back when it's true. But when it's false, you can be sure it's 0. So given this particular situation, the way this particular thing would be evaluated is if we looked at the precedence. We know that the in terms of precedence, the logical operators, like the logical operators is equal to, not equal to, less than equal to, greater than equal to, these have higher priority compared to assignment. So this operator has higher priority compared to assignment. So the way it's executed is something of this kind. So this is because is equal to has priority. So this is evaluated first. So j is equal to k is evaluated. J has a value 15 and k has a value 17. So is j equal to k? Because it's a comparison operator. So is j equal to k? No. So this is false. So when it's false, it returns a 0 back. So a 0 would be put into I. However, the values of j and k will not be changed because you are just comparing them here. You are not assigning or anything to do them. So the value of j and k will remain 15 and 17 respectively, and the value of I would be 0. let's run this program and check what the output is. So that's as expected. J is 15, K is 17, and I remains at 0. So hopefully that's a good start. Let's try and see what happens when I assign same value to J and K. So now I'm assigning the same value to J and K. So I has a value 1, but you cannot be sure that I would have a value 1. It can be any non-zero value. So it can be any non-zero value when the J and K have equal values. So if this result is true, this result of this operation could be any non-zero value. So anything other than 0 would be returned and the value would be stored into I, and that's what is printed. So that's the first example or the first puzzle we looked at right now. Now, the next program that we are looking at, the next puzzle, is a very simple one. It's about this statement. I'm doing I is equal to I plus 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 J. So will this compile? If so, why? And what's the result? Welcome back. I hope you have tried to guess the output. If you have not yet, do pause it and try and guess what the output would be. I'm going to run the program right now. So I've run the program right now, and the output, as you see, is I is 4 and J is 3. So I is having a value of 4 and J has a value of 3. The way this operation is evaluated is something of this kind. I plus 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 J. That's the way the thing is split up. So when the C compiler sees this kind of a stuff, what it really does is it takes I plus plus first and then does a plus J. So this is how the entire operation would be done. And when I run this program, as you can see, the value of I is 4 because the result of this operation is stored back into I, and whatever increment here is lost. So I plus plus is a post increment. So 1 becomes, this expression returns 1, this returns 3. So 1 plus 3 is 4 and 4 is put back. And J, the value of J is not really modified. If I really wanted to increment the value of J, then I should have done something of this kind. So this would now increment J. So the value of J which would be printed would be 1 more than what it is. And I'm doing a pre-increment in here. So the value of J is 3. So pre-increment 4. So the operation returns 4. And so I has a value 1. 1 plus 4, 5 would be put into I. So I would be 5 and J would have a value 4. So that would be the result of this particular thing which you see on the screen. I also have a variation. Let's just try plus plus I plus J. What would be the result of this? Try and guess. The values I becomes 5 and J is 3. So we are not changing the value of J here. So J is 3. All that would happen is J is 3 and plus plus I would actually increment the value of I, pre-increment, and the operation would return the the incremented value. So plus plus I would return a value 2. So 2 plus 3, 5 would be stored into I. So I would have a value 5 and J has a value 3, and that's what was printed down to the output. Let's end this by something of this kind. So let's try and guess what would be the output of this program. Will it be a compilation error? What would be the output of this particular program? Hope you got a chance to think about it. Let's run this program and see what's the output. So I is 4 and J is 3. The way this is treated, the way any time you see this plus plus is treated is when there's a space between two pluses, then these pluses act as an unary operator. So this acts as a unary plus operator. So plus 2, it's like you're saying plus of 2. It's basically these two pluses are almost kind of useless because even if you remove them, you would get the same output. So if you really want to do an increment, then it has to be a plus plus. If you give a space between them, C treats them as a unary plus operators which would not have anything at all. So it's almost like saying I want a +2. Similar to saying -2. It's like saying +2. So when you don't put anything, usually you mean +2, right? That's basically what we are representing. So if you give 2 pluses before it, then it is actually saying I want a +2, and then again it's a plus. So it doesn't really have any impact as such. So you can try this one. If this is confusing, try running this program and try seeing what the output is, and try to play around with it and try and get to know and get to understand what's happening with this script. So the summary is, when there is a space between your pluses, or it can even be your minuses, then these are treated as two negatives. So two negative and negative. So negative of negative in any language is positive, right? So this would be treated as positive, and the result does not change. I remains 4 and j is 3. So whether it, but if I did this, then the value of I would be decremented, and so the result of this operation would be I is 1. So I would return this operation would return 0. 0 plus 3 is 3, and the value of 3 is stored into I. So I becomes 3 and j is 3. So we looked at a lot of variations. The thing which you need to remember in this is, if you see two minuses right next to each other or two pluses right next to each other, then it's an increment operator, and that has higher priority at any time than the plus operator, single operator. But if there's a space between operators, then these are now unary operators. So this is minus I, and again a minus you are doing. So it's not minus minus anymore if there's a space between them. So it's a unary operator minus, and you have to treat it like your mathematics. So this one would be almost like similar to saying minus of minus I. So minus of minus I, it's plus I. So this would be almost evaluating. So C internally evaluates this and says this is minus of minus I, which is I. If you want to have a pre-increment or a post-increment, it should be something of this kind, minus minus. So that's quite a discussion, I guess, on pre-increment, post-increment, and how a unary plus and a pre-increment and post-increment operators evaluate. Let's just have one quick question. So I is equal to minus of minus 2. So what would be the result of this? So this would be a compilation error, because you cannot increment a constant. You can only decrement or increment a constant. However, if I said this, I gave a space in between them, what would be the output? This would result, because this is treated as minus of minus 2, and this compiles. So that's not a problem at all. So this compiles, this is almost treated like this, and the program stores 2 into I, and the value of j is not changed. So that's good. Let's look at one more puzzle. So look at this thing right now. Pause the video here, try and think what the output would be, and come back. Welcome back. Let's look at what the output is. So output is I is 0. So that's the value which is being printed. J we not do anything with, so we don't care about J here. So I is 0. Why is I 0? I is equal to 5. Is I is equal to 5? If we look at the order of precedence, not has a higher priority than logical operators. So the way this would evaluate if would be something of this kind. I has a value 0. Not I is a non-zero value, so not I is false, and false is equal to a non-zero value. So this would return a 0. 0 is equal to 5. No, that's not true too. So I gets a value of 0. If it was evaluated the other way, let's put a bracket around this. How would it have been? The way to have been is I is equal to 5 would be compared to 1 is equal to 5. No. So this would return a false. Not a false is true. So I would be assigned a non-zero value. So I get 1, which is representing the value true. So this is the negation operator. If we did something of this kind, remember that the negation operator has higher priority. So this would be the way the expression is evaluated. So this gets priority, and then this is evaluated, and then the value is assigned into I. And you can try and play around with assignment and precedence and associativity of the operators, because it's quite a tricky subject, and I'm sure a lot of people are interested in asking questions around that. So good luck with all the questions related to precedence, associativity, and all this kind of stuff. It's quite interesting and quite tricky as well. Until the next video, bye bye. Now let's move on to section 5 on functions. Functions is one of the important concepts related to structured programming, and having a very good understanding about functions is fundamental to programming. In this section, we would look at different puzzles which are related to functions. We look at the basics, then we would move on to part 2, where we would look at different things related to functions, more advanced things like passing a pointer to a function and things like that. And in the part 3, which we also call as advanced, we look at further various examples of puzzles related to functions. Welcome and good luck with this section. Hi there, welcome to this set of puzzles where we would talk mostly about functions. So in this particular example that we are looking at, we created a function called do nothing, and we said void do nothing, and yeah, it's not doing anything right now. I'm just calling it function. What would be the output of this particular program? Will it compile? I think that's the first question let's discuss about. So I hope you thought about it and you have an answer, and let's run the program. Okay, there's a compilation error. So basically, when you don't declare anything, the way it works is, if I don't declare something in here, I mean, I'm not declaring this function anywhere, right? I mean, all that I'm doing is providing the definition for this function. Let's start with that. So what is declaration and what is definition? Definition is the place where you are telling what the function does. So here you are telling what it does. So you're telling this function is right now does this in step 1, this in step 2, this in step 3, and all that kind of stuff. What does this function do? That's basically the definition of a function. Definition of function tells what the function does. If this function had a declaration, let's say we did define this particular function earlier, the declaration would look something of this kind. Declaration would be almost at the start of the program. So here I would say, what is the signature of this particular function? Signature of the function is called a declaration. A signature of the function usually have 3 different parts. One is, what is the return type? So the return type here is void. So that's the first thing. The next thing is name of the function. So name of the function is do nothing. So that's what we tell here. So the next one is name of the function. Next thing which we declare are the parameters of this particular function. So what are the parameters for this particular function? Those are the things which we declare. So all these combined are called the signature of the function. And for this particular method, the return type is void, the name of the function is do nothing, and we are not passing any parameters as such. So this is a declaration and this is a definition. And if I put a declaration ahead, then you would see that the program compiles and it would have run also, because we didn't do anything in do nothing. It doesn't show the output at all. That's fine. So this is declaration of a function which tells what is the signature of a function. So what's the signature? Signature is return type, function name, arguments. And the definition actually tells what are the different steps. So if I did something like printf, my step 1, printf step 2, I'm calling it do nothing and I'm trying to print something. So I would actually change the function name now to print something. So I'll do the same everywhere. This is one of the principles that you need to follow coding while coding. your function name should reflect what you're doing in the function. So it's really printing something. It's not really complete name as such, but it's better than do nothing for sure. So I go ahead and now run this program, and you'd see that step 1, step 2 are printed to the output. That's okay. But the most important thing that we were trying to learn is this is the declaration and this is the definition. And if I remove the declaration, what happens? If I remove the declaration, you'd see that C complains errors exist in the required project. Continue launch. I'll not launch it, but when I go here, it says conflicting types for print sum. What is conflicting types? When I don't declare anything, then C assumes a default declaration, and the default return type that C assumes is int. So it assumes that the declaration it expects is int print something. So it assumes that the default return type is int, whereas we are saying it's void, and that's the reason why there's a conflict and there is an error. If you want to use any function before its definition, so here main is trying to use the print something on line 5, whereas the function itself is defined on line 8. So when at this particular point the compiler doesn't know anything about the print something function. So as soon as it sees print something, it assumes that the default return type is int. And later when it sees line 8, it sees that the return type is void, and it says earlier I thought the return type is int, and now I see the return type is void. So there's a confusion. So compilation error. That's why you could actually do two things here to correct this. I can either put the declaration. So this declaration would tell line 3, okay, void print something. Compiler, there would be something called print something coming up soon. The return type of it is void. So expect that, and when the compiler sees that print something, I already know about it. So that's what it would be. So this program, if I run it, it would compile and it would print step 1 and step 2. The other way I could have got this working is something of this kind. So move the entire function right ahead. So put the function before main and now run it. This would work because before the compiler gets to line 9, it would have already seen the function definition, and it knows from the function definition that the declaration is something of the kind of print something and the return type is void. So I hope this discussion on definition and declaration is clear. So most important thing is before the invocation of a function, this is where you're calling the function, and this is called the invocation. Before the invocation of a function, you should tell the compiler about what the signature of the method is. You can do it in two ways, either by declaring it ahead or you can define it ahead itself. So either you can put the complete definition before the first invocation of a method, or you can put the definition later but just try and declare it earlier. So try and declare it earlier, and then you don't have a problem. So I hope this is a good discussion to have because this is something really important. Now let's say this print something is returning an int. What would happen? It would compile, because as I said earlier, the default declaration, when compiler sees print something, it would directly assume a default declaration of something, because it assumes that default type is int, return type is int, and no arguments are passed. So the program would still compile. So any other return type other than int, void, or any other return type would give you an error. This would give you a compilation.
If you are preparing for C interview, we have a complete C interview guide available. And if you are preparing for a C aptitude test, then we have C puzzles for interview as well. You can find the links to this in the description of this video. If you loved this video, then we are sure you'd love our other courses as well. We have more than 10 GitHub repositories with examples on C, Spring, Java, basic web application, Maven, Mockito. Whenever you are in need for examples, you can look these up. We have a number of courses created on ChalkStreet as well. You can search for in 28 minutes in chalkstreet.com, and there you go. Right now we have 3 different courses in here. I'm sure there will be a lot more courses and we have a lot of courses on C, Java, Spring, and a lot of Java related frameworks and web applications on Udemy as well. You might like some of the most watched videos on our YouTube channel. We have courses on design patterns, web applications, Maven, Spring, Eclipse, and web applications as well. Good luck with your learning. All the best for you. Until next time, bye-bye.